This screencast will go over our intro one-dimensional motion notes, leading us off in Chapter 2. Motion can pretty much be described with three different terms that you may have heard before: speed, velocity, and acceleration. Speed and velocity are very similar quantities, and we're going to get into that a little bit later. They both have to do with how fast an object is moving. Acceleration, on the other hand, deals with how quickly the velocity of an object changes, whether it's speeding up, slowing down, or changing direction. Looking at speed further, we kind of talked about this when we went over the units the other day. Speed is the rate at which distance is covered. So it involves both distance covered as well as the time it takes for that distance to be traveled. Units could be miles per hour. In the metric system, they could be kilometers per hour or meters per second. Anything that is a distance unit divided by a time unit. This is your first equation of the year, essentially. A lot of times you will see equations with only variables, though. So I could, write this equation as S equals D divided by T. Okay? Now, all three of these are quantities. We have a speed quantity, distance quantity, or time quantity. Whenever you give letters to something, as you know from algebra, these are referred to as variables. Okay? Something that you guys probably already know. So we'll now move to slide 3. Okay? If you can do a little bit of algebra, and you were probably just assessed on this, you should be able to rearrange that speed formula, solve for distance, and you can also do a little bit of algebra to also solve it for time. If we started with the equation that we had on the other side, right? Speed is distance. I know these letters aren't the greatest, so I'm doing this on my little pad on my laptop. The way that you would get distance by itself is literally multiplying by time on each side. And the reason why you would do that is you want to get rid of the time on this side, and they cancel, and you're left with distance equals speed times time, which we have right here. Okay? Now, if we go down here, right, if you take one other step, divide through by speed, you'll get to the relation for time. Okay? These two will not be on your formula sheet because they're essentially the speed formula just rearranged. Okay? You'll be expected to know how to rearrange them. Okay? Now, to go a little bit further, average speed deals with the motion of an object over a pretty long period or a far distance, because when if you take a car trip, you're not always going at the same speed. Sometimes you're stuck, at a red light. Other times you're moving at 80 miles per hour on the highway. So by taking the complete distance covered and dividing by the total time of the trip, you get your average speed. A lot of times, cars nowadays will have an average speed calculator on the dash based upon those two quantities. Now, on the other hand, you can also talk about instantaneous speed, which pretty obvious is the speed of an object at any instant in time. They don't necessarily have to be the same, because as we said earlier, over a whole trip you can go from 0 to 80, but your average speed would be somewhere in between. So instantaneous speed would be measured by, say, a police radar gun, and that's how you can get pulled over. You can also get pulled over from a cop when they have a little speed trap where they put the white lines on the ground, and in that case it's an average speed calculation, because you come into the trap and you might think, oh, I see it, and then you slow down real quick. The only thing they're calculating then is your average speed, not necessarily an instantaneous one. Object can move at a steady rate, move along at a constant speed, and if that's the case, its average and instantaneous would be the same thing, right? If you're always going 40 miles per hour, your average would be 40 miles per hour. It'd be like you getting an 80% on a test every single time. Your average for the course would obviously be 80 because that's all you ever got. Quick little example. I don't know if you've ever heard the tidbit that it takes 8 minutes for sunlight to go from the sun to the earth. And I might have mentioned this in class the other day. Light travels at a ridiculous speed of 186,000 miles per second. In order to solve for the distance between the sun and the earth, with the rearrange formula, time multiplied by speed, if you write your quantities here, right, 186,000 miles per second, you see that the time better be in seconds because that's the only way that these these units will cancel out and you'll be left with miles. Right? So 8 minutes is equal to 480 seconds because you had to, times by 60. Right, because there's 60 seconds in a minute, right? You could set up that factor label method like we just did yesterday, and you'll see that that distance is about 89 million miles. Clear the page. Now this is where we get into the difference between the terms velocity and speed. A common everyday person knows no difference between these two words, right? Essentially, they mean how fast an object is moving. In physics class, though, we're going to look at a little but yet very important difference between them. And that leads us to two new terms, scalars and vectors. A scalar is any quantity that only has a number associated with it, no direction. Right. Velocity, on the other hand, being a vector, is described by both size and direction. So if you said, something's going 60 miles per hour and there was no, direction associated with it, you just described a speed. Yet if you said, 60 miles per hour to the northeast, that would be a velocity or a vector quantity. Right? Other things that are scalars, for instance, mass, the amount of kilograms in an object. There's no direction with that, so that would be a scalar. Time is a scalar because, 3 minutes have gone by. That's not 3 minutes to the southeast. Temperature is also a scalar, right? It's 75 degrees outside. You wouldn't say it's 75 degrees to the northeast. That makes absolutely no sense, right? So all quantities can either be a scalar or a vector. In this case, speed is scalar, velocity is vector. Right. Now, a question that kind of illustrates the difference. Right? Say you had a vehicle moving in a circular path at a constant 60 miles per hour. Two questions. Does the vehicle have constant speed? Does the vehicle have constant velocity? You can always pause these videos if you want to think about the answer before I kind of go over the answer. Okay, so this might be a good spot to do that. Okay. Now that you've thought about it, we'll kind of reveal the answers here. Whoop. I guess I'm just going to say it. I thought I had it on another slide. Does it have constant speed? Well, yes, because we said speed is just how fast you're going. So you're always going 60 miles per hour. But the follow-up question, does it have a constant velocity? That one would be no, because although you're going 60 miles per hour the entire time, the direction of the vehicle is always changing. Right now it's moving this way. A little bit later it's moving this way. A little bit later it's moving this way. Right? This little arrow. Arrows are usually used to represent vectors because they show how fast and also in what direction you're moving. Okay. Now, if you would like to look a little bit more in this section, these notes match up with pages 18 to 25 in your CP textbook, so you could read through that. I would also look at the conceptual questions on page 33, numbers 8 through 14. They are a good follow-up to this screencast. And I wouldn't worry about it, but just to give you a heads up, we will be doing some mathematical speed problems in class on Tuesday, which I will be able to help you with within the class rather than you getting stuck on them at home. Okay? Have a good Labor Day weekend, guys, and I shall see you on Tuesday.